Schrödinger's cat is often dismissed as a quirky thought experiment or a physics meme, but its core reveals one of the deepest paradoxes in quantum mechanics. At the heart of it lies the unsettling idea that the world, at its most fundamental level, may not obey the rules of common sense. The scenario imagines a cat in a sealed box, where its fate is linked to a quantum event, the decay of a radioactive atom. If the atom decays, a vial of poison is released, killing the cat. If it doesn't, the cat lives. But the twist comes when we consider quantum superposition. Until we open the box and observe, the cat is described as both alive and dead, simultaneously. This is not because the cat is physically flickering between life and death. Instead, it's a reflection of how quantum systems behave before they are measured. In quantum theory, particles don't have definite properties until they are observed. They exist in a cloud of probabilities, described mathematically by a wave function. Schrödinger's cat translates this abstract idea into a macroscopic image, a living creature caught in the web of quantum uncertainty. The real purpose of the experiment was to highlight how absurd the implications become when we extend quantum principles to everyday objects. Yet, modern interpretations of quantum mechanics have only deepened the mystery. The Copenhagen interpretation, once dominant, holds that observation collapses the wave function into one reality: the cat is either alive or dead, and our act of looking forces nature to choose. But other interpretations, like the many-worlds theory, suggest that both outcomes occur, in separate, branching universes. In one, the cat lives; in another, it dies. We, the observers, split as well, each experiencing only one of the outcomes. This interpretation avoids wave function collapse altogether, but at the cost of an ever-growing number of parallel realities. From this perspective, Schrödinger's cat is more than a paradox. It's a gateway to questions about the nature of reality, consciousness, and the role of observation. Does reality exist independently of our perception, or is it shaped by it? Are we passive witnesses to the universe, or active participants who help define its structure? The cat in the box isn't just a feline, it's a mirror reflecting our struggle to understand a universe that behaves differently depending on how, or even if, we look. Furthermore, the experiment exposes the tension between the quantum world and the classical one. On the scale of atoms and electrons, superpositions are natural, measurable, and even utilizable, as in quantum computing, where bits can be in multiple states at once. But in the macroscopic world we inhabit, things seem definite. Cats are either alive or dead, never both. This suggests a boundary, a threshold where quantum rules give way to classical behavior. But where, exactly, is that boundary? Physicists still don't fully know. Technological advances are now pushing that boundary. Experiments have shown superpositions in increasingly large and complex systems, not cats, but molecules and tiny mechanical oscillators. These results challenge the classical quantum divide and raise the possibility that, under controlled conditions, larger and more visible objects could exhibit quantum behavior. If so, the cat's dual state wouldn't be just metaphorical, it might one day be physical, observable, and even engineered. This opens the door to an even more provocative line of thought: if superposition can scale up, then where does consciousness enter the picture? Some physicists and philosophers have speculated that the act of observation, and by extension, the presence of a conscious observer, plays a crucial role in the transition from quantum ambiguity to classical reality. This idea, though controversial, has led to proposals that consciousness may not just observe reality but might actually be required for reality to crystallize into a single, definite state. This doesn't mean that human minds collapse wave functions by mere thought, but it does raise the question of what counts as a measurement. Is it a mechanical interaction, like a photon hitting a detector? Or must there be awareness? Such questions blur the line between physics and philosophy, but they're taken seriously because quantum mechanics has defied all attempts to fully interpret it without paradox. Schrödinger's cat is still very much alive, as a symbol of unresolved tension between theory and experience. Decoherence theory has offered a partial resolution. It explains how interaction with the environment causes quantum systems to rapidly lose their coherence, their ability to maintain superpositions, and settle into classical states. In other words, the world is constantly measuring itself. A single particle in isolation might remain in superposition, but when it bumps into air molecules, photons, or atoms in its surroundings, its wave function effectively collapses. The cat's fate, in this view, becomes definite not when we open the box, but when the quantum system becomes entangled with its environment. Yet decoherence doesn't explain why one outcome is realized instead of another, only that superposition becomes practically undetectable. The deeper issue remains, the measurement problem. At what point does potential become actual? Why do we experience a single outcome instead of a blend? Schrödinger's cat remains the perfect metaphor because it lives, and dies, at the intersection of theory, reality, and perception. It's not a joke, it's a puzzle we still haven't solved, a challenge to our assumptions about existence itself. Even today, as quantum mechanics underpins everything from semiconductors to lasers, the philosophical implications of the cat experiment remain unsettling. It suggests a universe not of solid objects, but of potentialities, probabilities, and entangled states. Our classical world emerges not as the fundamental layer of reality, but as a kind of approximation, a simplified picture of something far stranger beneath the surface. And so, when we speak of Schrödinger's cat, we are not merely recounting a curious experiment from the 1930s. We are pointing toward the very limits of human understanding. We are asking, what is a fact? What is real? Is the world out there, independent of us, or does our involvement, even our questions, play a formative role in shaping what exists? As we push deeper into the quantum realm, our tools grow sharper, but the mystery only thickens. Experiments with quantum entanglement, for instance, show that particles separated by vast distances can instantaneously affect one another's states. Einstein famously called this spooky action at a distance, yet it has been repeatedly confirmed. This non-locality further destabilizes our classical intuitions. How can information leap across space without traversing it? And if two entangled particles behave like one system, what does that say about individuality, separateness, or even identity in a quantum world? Schrödinger's cat is entangled too, not with another particle, but with a whole cascade of possibilities. And when you open the box, you don't just discover the cat's fate, you participate in resolving a quantum uncertainty. In doing so, you become entangled with the cat's outcome. Your observation isn't passive, it's part of the system. Some physicists go further, suggesting that all observers are embedded in a web of quantum correlations, constantly collapsing possibilities into history, carving the arrow of time from a field of timeless potential. This brings us to the idea of quantum histories, the notion that what we call the past may itself be fuzzy or dependent on present measurements. It's an unsettling proposition, that reality might not be simply there, waiting to be recorded, but woven together from countless interactions. In some interpretations, the very distinction between observer and observed breaks down entirely. There is no outside to the universe, no privileged perch from which to objectively watch. We are not above the system, we are inside it, part of it, emerging from it. In that light, Schrödinger's cat becomes a philosophical compass. It doesn't just challenge the boundary between life and death, or between micro and macro, but between epistemology and ontology, between what we know and what is. The cat asks, is the universe deterministic, with hidden variables lurking beneath the randomness? Or is indeterminacy not a flaw in our knowledge, but a fundamental trait of existence? And the implications aren't just abstract. Quantum mechanics is already reshaping technology. Quantum cryptography promises unbreakable codes, quantum sensors may detect the tiniest gravitational waves, quantum computers, still in their infancy, could one day solve problems beyond the reach of any classical device. But each of these developments leans on principles that are still, in some ways, not fully understood. We're building machines with tools forged from mystery. And perhaps that is the most humbling truth of all, We are engineering the future with theories that defy our classical intuitions, that work impeccably in practice but remain elusive in meaning. Schrödinger's cat sits at the crossroads of this paradox. It reminds us that our most powerful scientific framework is also our most mysterious, a theory that predicts everything and explains almost nothing in terms of why it works the way it does. The cat's box becomes a stage for human questions that extend far beyond physics, about knowledge, reality, causality, and even mortality. If a cat can be both alive and dead until observed, what does that say about death itself? What is the nature of being, if being can exist in limbo, waiting to resolve? These aren't just metaphysical musings, they arise naturally from the logic of the equations. The line between science and philosophy, long seen as a boundary, begins to blur. And this blurring is not a weakness, it's an invitation. An invitation to think more deeply about our assumptions, to recognize that the universe may not be built to conform to our expectations. That its logic may be non-human, even post-human. Schrödinger's cat isn't absurd, we are absurd for thinking the universe must behave like a tidy stage play, with clear acts, fixed roles, and a well-lit backdrop. The cat's fate isn't a riddle to be solved once and for all, but a doorway into continual inquiry. This is why the thought experiment has endured. It has become a cultural symbol, not because people misunderstand it, but because they intuitively sense its gravity. Behind the image of the cat is a confrontation with the unknown. It is a story that forces us to sit with paradox, to accept that some questions may not yet have answers, or may have many. It challenges us to admit that the foundations of reality might be stranger than fiction, and that wonder is not something to grow out of, but to grow into. Quantum mechanics, with all its predictive success, has not yet told us what reality is. But it has told us something profound, that the act of questioning, of observing, measuring, testing, is not separate from the world, but woven into its very fabric. Schrödinger's cat may be trapped in a box, but we are the ones staring into the dark, waiting to find out not just what's inside, but who we are for looking. And in that darkness, something extraordinary happens. The more we look, the more we realize that the box is not merely a container of paradox, it is a mirror. Schrödinger's cat reflects not only quantum uncertainty, but our own uncertain place in the cosmos. We are both observers and participants, thinkers and systems, beings capable of measurement but not immune to what we measure. Every question we ask bends reality just slightly, subtly shifting the field we're trying to understand. This realization reverberates far beyond laboratories and equations. It touches art, consciousness, and even ethics. If observation affects outcomes, then perhaps attention itself, what we choose to focus on, to measure, to care about, has creative power. In a quantum universe, choice may not just be a passive selection of possibilities, but an active force in shaping which branch of reality unfolds. The cat reminds us, there are always multiple futures waiting in superposition. Which one becomes real may depend, in part, on what we dare to imagine. And that brings us back to the cat, silent, unseen, and yet central to modern science. It's a metaphor that refuses to die, precisely because it captures the in-between. Not just between life and death, or between theory and observation, but between knowing and not knowing. It invites us to dwell in that liminal space where knowledge is still forming, a space where curiosity is not just allowed, but required. We no longer laugh at Schrödinger's cat. We learn from it. It speaks to the deepest questions of physics and philosophy, and refuses to let us go. The experiment never ends because we are always reopening the box, not just in labs, but in thought, in wonder, in every attempt to grasp what it means to be in a universe that might not fully reveal itself unless we reach for it. And so the cat, both a symbol and a scientific oracle, waits. For each new physicist who questions measurement. For each new student who stares at a superposition and sees a paradox. For each new mind willing to ask, if the universe is this strange at its roots, what else might we not yet see? Want me to take it even further? maybe into how it applies to time, identity, or simulation theory. Yes, let's open the next layer of the box, time. In our everyday experience, time flows forward, cause precedes effect, memories accumulate in one direction, and the past is fixed while the future remains open. But in quantum mechanics, time isn't quite so straightforward. The fundamental equations that govern particles, like the Schrödinger equation itself, are time-symmetric. They don't distinguish between past and future. This raises a startling implication: the boundary between what has happened and what will happen may not be as sharp as it seems. If a quantum system can exist in a superposition of states until observed, then does the act of observation determine only the present, or can it retroactively influence the past as well? Some interpretations, like the transactional or two-state vector formalism, suggest that quantum systems are influenced not just by initial conditions, but also by future measurements. That is, the future can reach back and help shape the past. In this view, the cat's fate might depend not just on what happened inside the box, but on what will be known about it later. This throws our classical notion of identity and cause-effect into question. If time is not a one-way street, then neither is the self. Who we are, as observers, thinkers, agents, may not be written solely by past experiences, but also by future interactions. The self, like the cat, may be in superposition, an evolving probability field that only becomes definite through continual acts of reflection, memory, and choice. And from here, we enter speculative but fertile ground, the simulation hypothesis. If quantum reality is fundamentally probabilistic, if particles do not resolve until observed, it begins to resemble an optimized system, one that conserves computational resources by only rendering what is needed, when it is needed. Like a video game that only generates a landscape when the player turns toward it, the universe might only solidify when observed. Schrödinger's cat, then, would be a consequence not of physical indeterminacy, but of an informational economy, a cosmic rendering engine awaiting an input signal. Is this a metaphor, or a clue? That depends on how seriously we take the resemblance between quantum uncertainty and digital compression. Quantum systems store and process information in ways classical systems cannot. Some theorists have even proposed that spacetime itself might emerge from quantum entanglement, that geometry and gravity are not fundamental, but derived from a deeper informational substrate. In this frame, the cat's paradox is not just about life or death, but about existence itself. What does it mean to be if being is conditional? If existence, like a waveform, is a function not only of the system but of its interaction with other systems, with consciousness, with memory, with time, Schrödinger's cat becomes more than an experiment. It becomes a challenge to the very categories we use to think: real/unreal, observer/observed, now/then, alive/dead. It invites us to build new categories, or to live without them entirely. In the quiet darkness of that sealed box, Schrödinger's cat waits, not for breath or heartbeat, but for meaning. It is the most silent participant in the loudest conversation physics has ever dared to hold: what is real? What is known? And where, in all this, are we? We thought we could cut the universe cleanly, divide observer from observed, theory from fact, particle from wave, past from future. But the cat whispers otherwise. It teaches us that boundaries blur, that the act of watching and the thing being watched are deeply intertwined. That knowledge is not the uncovering of a fixed world, but a dance, of probabilities, of choices, of questions that shape the very answers they seek. In that sense, the cat is not just a metaphor. It is a doorway. A doorway into a universe that is not static but alive with potential. A universe where even nothingness is full of trembling possibilities. Where particles choose paths not through fate, but through entanglement, symmetry, and chance. Where observation is not a passive act, but an active sculptor of what is. Where you, by asking, are part of the unfolding. And perhaps this is the lesson that lingers: the box is not sealed. Not truly. Every time we confront uncertainty, every time we peer into the unknown with curiosity instead of fear, we lift the lid a little. Every question we ask, in science, in thought, in wonder, is the turning of a key. In the end, Schrödinger's cat is us. Superposed. Searching. Undecided. Both bound by mystery and born of it. We are the ones caught between what is and what might be, between the sharp clarity of logic and the soft blur of awe. And when we open the box, not to collapse a wave function, but to face the wonder, we find not a cat, but a mirror. And in that mirror, possibility. Let us go further still, because the mirror doesn't just reflect, it invites us inward. When we look into the quantum world, we are not only peering into the smallest scales of matter, but into the deep architecture of thought itself. What does it mean that nature seems to resist definition until we engage with it? Why do our questions change the answers? Perhaps consciousness, long treated as an afterthought in physics, is not on the sidelines of reality, but woven into its core. This is not mysticism. It is the logical end of a theory that refuses to disentangle the observer from the observed. Schrödinger's cat tells us that reality is participatory, that measurement is not just reading data, but making something real. And that truth may not pre-exist observation, but be born alongside it. And so the implications stretch far beyond physics, into art, memory, time, and being. If the universe is constructed not from fixed particles but from evolving relationships, then meaning itself may be relational. Identity, like a wave function, is not a point, but a spread, shaped by context, history, entanglement. We are not static selves moving through a fixed reality, but probabilistic beings surfing a sea of unfolding interactions. Our choices matter, not just morally or emotionally, but ontologically. They carve the branches of the world we inhabit. This brings us back to awe. Quantum mechanics doesn't just reveal the strangeness of the universe, it reveals our deep, ancient desire to know the universe. And in that knowing, to find our place within it. We are the species that opens boxes, that builds paradoxes into thought experiments and stands astonished when the answers are stranger than fiction. Perhaps that is what Schrödinger gave us, not a cat, not a contradiction, but a living metaphor for the unfinished nature of truth. The cat's half-life is our own, part question, part answer, flickering between certainty and mystery. So as we move forward, into quantum computers, into teleportation experiments, into the next great revolutions in understanding, we carry the cat with us. Not in a box, but in every act of curiosity. In every refusal to settle for easy answers. In every scientist, philosopher, poet, and child who dares to ask, but what if? Because maybe the greatest lesson Schrödinger's cat has to offer isn't about physics at all. Maybe it's this. The unknown is not something to fear. It is something to love. To open. To become. Shall I continue into a final epilogue or reflection? Yes, let's complete the journey with an epilogue. Underscore 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 underscore. Epilogue: The cat beyond the box. In the end, Schrödinger's cat walks free. Not because the box was opened, but because we learned to live with it closed, to accept that mystery is not the absence of knowledge, but the presence of potential. The cat survives not as flesh and bone, but as symbol, as a whisper echoing through the equations, the classrooms, the dreams of physicists tracing the edges of the real. It reminds us that truth is layered. That certainty is rare. That even the most precise science still contains an ember of wonder that refuses to be extinguished. And that this is not a weakness of physics, it is its deepest strength. For what kind of universe would this be, if it could be completely understood by the creatures within it? What kind of mind would we have, if it could look at the stars, at atoms, at life, and feel no vertigo. No, the cat stays with us because it tells a greater story than just quantum mechanics. It tells us that the act of seeking is sacred. That meaning is not delivered to us by the cosmos, but co-authored in our questioning. That every box we dare to open, in thought, in science, in ourselves, may contain not one answer, but 1,000 paths. Some alive. Some dead. All real. So we go on. Measuring. Wondering. Becoming. Each of us a paradox, observed and observer, particle and wave, cat and question. And if someday the cat fades from textbooks, if the metaphor becomes outdated in light of deeper theories, let us not forget the gift it left behind. A universe that is not passive, but participatory. A cosmos that speaks, if we are willing to listen with both rigor and humility. A reality that does not end with knowledge, but begins with it. And perhaps, above all, that truth, like the cat, is not found by standing outside the box, but by daring to step inside. Schrödinger's cat walks free, not into a world of simple truths, but into one teeming with layered realities. It slips between the cracks of logic and intuition, science and soul. The box, once imagined as a sealed prison of uncertainty, becomes something else entirely, a symbol of every boundary we encounter between the known and the unknowable. The cat is no longer trapped. We are the ones enclosed, not by metal walls, but by our desire for absolute answers. By our need for binary outcomes, alive or dead, true or false, certain or impossible. But the quantum world does not conform to these sharp divisions. It hums with ambiguity. It resists collapse. It asks us to sit, not with closure, but with openness, and to find comfort there. This is not a failure of science. It is its highest invitation. In a sense, the box becomes a kind of altar, a quiet chamber where we confront the sublime. The cat lies at the intersection of dualities, wave and particle, mind and matter, presence and absence. It embodies the whisper that reality speaks not only in facts, but in possibility. The box holds the tension between what is and what could be, a superposition not only of physical states, but of meaning itself. And meaning, in this universe, is no longer a fixed structure handed down by the cosmos. It is an emergent property. A co-creation. As if the laws of nature, in all their mathematical precision, still leave room for poetry, and for participation. Because what Schrödinger's cat ultimately teaches is that we are not separate from the experiment. Every observation, every theory, every act of curiosity alters the equation. The observer is not a passive recipient of truth, but a necessary player in its unfolding. This dissolves the old myth of detached objectivity. The universe is not a machine to be watched, it is a field to be entangled with. And what of time? The arrow we thought moved cleanly from past to future. In the quantum world, time can blur. Cause and effect can interweave. Some theories even propose that the future may influence the past. In such a reality, the cat's fate is not just unresolved in the present, it may be shaped by what lies ahead. The implications are staggering. They stretch beyond physics, into consciousness, into the philosophy of self, into how we live. If identity, like a quantum state, is dependent on context and entanglement, then the self is not a singular unit, but a process, ever-shifting, collapsing into definition only moment by moment. We, like the cat, are superpositions, of dreams and doubts, choices and chances, memory and projection. To exist is not to be, but to become. And what does it mean, then, to open the box? It means to risk transformation. To step into the unknown not as a trespasser, but as a collaborator. It means acknowledging that every act of perception is also an act of creation. That meaning is not something we find, but something we form. That the boundaries between physics and philosophy, between fact and value, between experiment and experience, are more permeable than we imagined. Schrödinger's cat will not give us a simple answer. It never did. Instead, it leaves us with something far greater, a metaphor that lives, that breathes, that evolves, just as science does. It walks with us into quantum computers and dark matter detectors, into particle accelerators and thought experiments. It curls beside our equations and sleeps in the spaces between them. It appears in classrooms, in paradoxes, in every child who asks, what if the universe works differently than we think? Because it does. The cat is not just a curiosity of 20th century physics. It is a whisper of 21st century potential, and a warning. That if we cling to old models of truth, we may miss what is becoming. That if we demand certainty, we may lose the beauty of emergence. That the universe is not a solved problem, but a symphony still being composed. And each of us, in observing it, in questioning it, in wondering, becomes part of its music. So let us not close the box again. Let us carry it forward, not as a cage, but as a compass. Because in that box, in its paradox and its poetry, is everything we need to know. That mystery is not the enemy of knowledge. That possibility is not weakness, it is life. That we are not spectators, but participants. And that the universe, in all its wild and trembling quantum depth, is still unfolding. Because the cat is not dead. The cat is not alive. The cat is inviting you to look. And to become. Imagine this, not a lab, not a box, but the vast silence between stars. In that silence, something stirs. It is not a particle, not a theory, not even a thought. It is a question, the same question that Schrödinger encoded in that impossible feline puzzle. That question echoes across quantum fields and consciousness alike. It shatters the illusion that the universe is a cold, silent machine, ticking independently of us. No, reality is relational. It is in flux. It is waiting. The cat becomes more than symbol. It becomes a cipher, a quantum riddle that encodes the logic of dreams and particles alike. When you think about it long enough, when you follow its threads from Copenhagen to Everett, from entanglement to decoherence, from wave function to observer effect, something strange begins to happen. You realize, this isn't just about physics. This is about the nature of everything. About why the stars exist at all. About how a mind, yours, arose from a soup of molecules that once danced in quantum foam. About how that mind now questions itself, using a cat as a mirror. And perhaps the final twist is this. The box was never sealed. There never was a cat. There never was poison, or decay, or a ticking Geiger counter. There was only a single, breathtaking truth, disguised as paradox. And now, you are inside. Inside the wave. Inside the superposition. Inside the story that the universe has been telling since the first quantum fluctuations of the Big Bang. That uncertainty is not chaos. It is freedom. It is creation. It is the breath of a cosmos still learning what it can become. We thought the cat was trapped. But maybe the cat was the key all along. Maybe, just maybe, Schrödinger's cat was never a warning. But a summons. A summons to think differently. To stop demanding the universe behave like a tidy mechanism, and instead, to listen to its mystery. To stand not above it, but within it. To know that you are not separate from the experiment. You are the experiment. And if that is true, then maybe the box is not a cage, but a chrysalis. And you, the observer, the dreamer, the wanderer through these fields of light and shadow. You are not here to find the answer. You are here to become it. The universe does not ask for belief. It does not knock. It does not explain. It waits. It waits for eyes to open. For instruments to align. For questions brave enough to disturb the silence. It waits for an observer, not just to watch, but to awaken. Schrödinger's cat is not a puzzle to solve. It is a veil to lift. A riddle placed in our path by a cosmos that refuses to be one thing, because it is many. Alive and dead. Particle and wave. Fact and feeling. You, and not you. In the moment we first imagined that cat, sealed away in quantum limbo, we unknowingly wrote ourselves into the same equation. The cat was never alone in the box. We were there too. Because we are the ones who look. And looking is the first act of creation. We imagine we are spectators, passive, external, scientific. But the laws of the quantum tell us a more dangerous truth: we are entangled with the world we see. There is no neutral gaze. No safe distance. Even silence echoes. Even a closed box resonates with meaning. And what is the cat, really, if not a symbol of possibility before choice? A portrait of potential not yet collapsed into history. A reminder that every reality must be chosen, and in choosing, something is left behind. In the quantum universe, nothing is fixed until interaction. And in our lives, nothing becomes real until we choose to engage. The cat waits, because all possibilities do. Each fork in the timeline. Each idea not yet spoken. Each truth not yet dared. You are not merely in the universe. The universe is in you, observing itself through your questions, sculpting futures with your attention. The wave function doesn't collapse out there. It collapses within the one who chooses. So what will you measure? What box will you open? What paradox will you embrace, not as a contradiction, but as a doorway? Let go of the need for certainty. Let go of the demand for the cat to live or die. Let go of the illusion that your role is to decide what is. You are not here to conquer truth. You are here to dance with it. To fold yourself into its mystery. To collapse with it. To rise again, radiant, into new superpositions of meaning. Because even now, after all the equations, after the debates, after the interpretations that spin like galaxies around the problem, the cat still waits. But it waits no longer for a physicist. Not for an answer. Not for a theory. It waits for you. The one who dares to wonder. The one who hears silence and doesn't fill it, but joins it. You, the observer. The anomaly. The equation and the error. The boundary crosser. You are Schrödinger's cat. You are the box. You are the moment before the lid opens. And the world becomes real.